Alright, hello my friends. Today we're going to be covering projectile motions, two-dimensional kinematics. So basically, let's get down to, I think we can cover what projectile motion is first, and then I'll also cover down the actual breaking down of x and y's. So let me just go. So what is projectile motion? Oops, sorry about that. Pretty tired, I'm not gonna lie. WORK 17 hours. Um, so projectile motion is an object moving in two dimensions. So in this case, x and y, horizontal, vertical, under the influence influence of gravity only. I feel like I should highlight that part. There we go. So it's just an object under the influence of gravity only. That means it cannot be under the influence of any other, well, weird forces. So let's say, example, kicking a ball. All right, you kick a ball to your friend, and oops, you hit him on the face. Kicking a ball. All right, let's move this down so it's a bit more spaced out. There's no need to be cramped. There you go. So you're kicking a ball. Here's the ball, right? And you don't kick it straight horizontally, no, because you're cool. You know how to kick a ball. So you kick it like this, bit up at an angle. All right. And so under the projectile motion, of course, a note, we're always going to ignore air resistance in AP physics. And so there's a note, ignoring air resistance. For all these projectile motion problems and most problems, we're always going to assume a gravity of 9.8 in your problems so you can get used to real math. And then in your tests, or more specifically on your AP exam, you'll be using a estimated gravity of 10 meters per second squared. And you'll be ignoring air resistance unless otherwise provided with that information. So ignoring air resistance, this is the neat part, its path is a parabola, which makes sense. Its path is a parabola. In case you don't know what a parabola is, it's just this type of shape. One's cut in the middle. It is perfectly symmetrical, mirrored, basically. And so its path, or its projectile motion path, would be like that. Right? Beautiful. So, recall. Here we go. A vector can be, sorry, a vector can be resolved into an x component, and this is what I'm talking about, the breakdown of vectors, an x component and a y component. Now I feel like this is an extremely important thing. I'm just gonna highlight it like that. I feel like the breakdown, a lot of people actually like go past this. It's very important. A lot of people tend to forget the breakdown, and sometimes they will use the whole thing, or sometimes they don't even know why you're breaking it down. And so, you know, it's very important because at the end, right, these two different types of components are completely different. Usually, and not always, by the way, usually the X frames, so the components, and the y one, so the y frame of reference, right, from an object are unrelated, right? That means um, okay, that means that they do not impact each other. So they don't. Actually, let me write that down here. Don't impact each other. So when you're breaking down vectors into x and y's, remember that they are singular, right? They are one and one, right? And it's vertical and it's horizontal. The horizontal does not affect the vertical, right? They're different things. And so, um, okay, yeah, and here we go. And what's a projectile then? Well, similar to the definition from before, but for projectiles specifically, when we're talking about the x and y breakdowns, the x motion, so the horizontal, is constant, okay? And this is very important. It's a constant velocity. And then for y motion, the acceleration is constant. Okay. So, oh, and in this case, for most projectiles, it's just gravity. You'll get used to that. But yes, gravity's always there. So, for a low note, for a projectile motion problem, break it up into x and y frames. All right. So similar to how the way we solve our questions, right? For any types of vectors, we always try to identify the x and y's. Okay? So when you're like reading a question, you're trying to identify, oh, what variables do I have? What is this question really asking me for? What equation will I use, right? For the vectors, you'll be like, okay, what am I breaking down here? How do I break it down? Will I be able to break it down? And the most important thing is, do I need to break it down? Okay. A lot of the time, they may be trying to waste your time, and so you need to notice and kind of like know what you're doing. But in case you're wondering, how can we relate these x and y frames? Time, t, is the bridge between them. So time is a universal thing, and time will always be used for both. Mhm. And yeah, so let's actually get down into how you would break things down. So let's say we have a velocity right over here, and then we're trying to break it down into its vertical and horizontal, like this. All right. So that's how you would visually break it down at an angle. So here's the angle, and then this would be called the. I always call it like this. Okay. And so using so let's say we know what the axis would be v um so yeah, and then if you're wondering how to get the equations for each one, so you just use like SOHCAHTOA and trigonometry. Um, and so using that, we can figure out that the horizontal component of the velocity, that would just be the velocity cosine theta, okay? And then for the vertical, it's velocity sine theta. Now this is just a broken down version. Simplified version. of isolating for this. And reality, obviously, do that, blah, blah, blah. And then you find this, and then blah, 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 blah. And then you can just isolate for this. And then if you ever want to find the actual vector, this can happen a lot. You would just have to use the v squared equals plus. Or a neat little trick I use is just doing this. Most of you may already do this, but you just plus vy squared. So you can just do these and then square root the total answer. And so that skips the total step of just, getting this, adding them, and then square rooting the whole thing. I prefer this method a lot. It saves a lot of time. It can introduce some variable to errors. So make sure to always show your steps. So anyways, these are pretty important. You don't have to memorize them, obviously, but you should, like, you will know these, and they're really not that complicated. You just have to understand what you're doing. So take your time. Don't get confused. Try to, do more practice problems. And talking about practice problems, let's do some. So let's practice. Let's practice a simple one. Okay. So, okay, I remember this one from my test. I did pretty bad on my first test. So let's say a rock is thrown horizontally. Right, that's important. Horizontally, off a 20-meter cliff of a 20-meter cliff with a speed of 5 meters per second. So A and B as always. How long does it take to hit the ground? Does it take to hit the ground? Okay, there we go. And then how far does it travel horizontally? So the distance. What is distance traveled horizontally? That's a better shaped question. So how long does it take to hit the ground? Well, here we're just trying to figure out what's the vertical distance. Okay. And so to find that out, obviously you can use kinematics, but you could also just use like your brain. I don't know how to say this, but remember that acceleration equals gravity. Gravity equals 9.8 squared. And so obviously you can use the calculus derived. So half at squared. So that is also another important equation. This one is derived from calculus, but nonetheless, oh yeah, sorry, vertical acceleration t squared. But this is just the, it's obviously from the kinematics. You can see it pretty obviously, but it's just short. So you don't have to memorize this. Kind of comfortable with the kinematics, but so then we can just plug it in quite easily. So we're trying to isolate for, oh wow. So then let's plug in everything. Okay. Well, actually, it would be easier to actually no. Remember what we do? We always isolate for variable first and then plug in. So we times by 2. There we go. Yeah, t squared and divide by y. T squared equals, so t would be equal to around the 2 t t. Sorry, not t. Acceleration in the vertical. Try to always do subscripts normally and do them well. Obviously, you can get confused, but I always find it super useful to mark them down with x's and y's because at least you know what they're breaking down and why they're different. In the vertical sense, it's being pushed down or accelerated by gravity, but horizontally, there is no acceleration, but it's a constant speed. So here we can just now plug in, so the square root of, we know the distance because it says right here, it's thrown off horizontally of a 20-meter cliff, so that's the vertical distance. We assume obviously that it does touch on the ground, or else, it would just be floating there, right? 220 by 9.8, and the time should be around 2 seconds if I'm correct. Think about it like mentally. If the acceleration, we can estimate it to be around 10. If it's 20 meters, it should only take around 2 seconds because then it accelerates to that velocity and just lands on the ground. So let's actually do it using our calculations. So 2 times 20, 40, divided by 9.8, we have and then square root. So we have a time of approximately 2.02 seconds. All right, so that's the final answer for A. So yeah, that makes sense as we just confirmed with how gravity works. And now, what is the distance traveled horizontally? All right, there we go. So here we can just use our beautifully designed simple equation. So distance divided by t, and therefore distance equals velocity times time, which makes sense. If I travel 5 meters per second and my time is 2 seconds, my distance will be 10 seconds. So now we just have to rewrite this question because remember, we're dealing it in a horizontal sense. So most of these will be in x dimension, except time, because remember, time is universal and time is the bridge between many in the future, many different things. Time is a beautiful thing. Um, so yeah. So the horizontal would be 5 times 2.02. Remember, time is the same for everything because if, let's say, always draw a diagram, right? And I throw it down like that. It's moving this way in the horizontal, 5 meters per second, and then it lands over here in 2 seconds. So that means, once it lands, there's no more velocities. It is stationary. Therefore, the time will be equal in both. Yeah. So therefore, it would be around 5 times 2.02, 10.1 meters. Remember SI units. Yeah, there you go. That's a very nice simple problem. Sometimes you can get tricked because you'll use gravity in the horizontal. Obviously, that is wrong. Just be confident with yourself. Practice. If you're not sure, please do ask. Um, there's nothing worse than not asking. So yeah. Now this one's very nice. Let's say we launch thing straight up. This one is always very useful. It's an example I personally use a lot in real life, and it's very commonly asked really in physics. I don't know why. But let's say a ball is oops, sorry about that. Just clicked off. A ball is thrown off. Well, I wouldn't say thrown off, but thrown vertically. So that means upwards. So vertically upwards. Oops, sorry about my handwriting. So ball is thrown vertically upwards with the speed. Uh, I don't want to make it too easy, so let's go 50 meters per second. Okay. So A and B. This is a really simple question, but it can actually be quite tricky for some people. How high does it go? Okay. So hint. Oh, always. By the way, always feel free to try these problems on your own. So just pause or anything. Um, if you can't really read it, just rewind and try to listen what I'm saying. I always make sure to read these out loud in everything I do because I understand that my handwriting is quite bad. So how high does it go? Hint. Um, it's being thrown vertically, so that's distance y, and then b would be how long it's in there. So that's time, which is the universal. How long is it in the air for? Okay. All right. Sorry about that. So how high does so here we're dealing with the vertical senses. Okay. So how high does it go? This requires a bit of knowledge, a bit of understanding, but it's quite simple. I think I explained this in one of my last videos, but if I throw something upwards, there's a moment in time, a very specific moment in time, where it starts coming down, right? For everything thrown upwards with a velocity, gravity is bringing it down. And there's one single moment in time where it's equalized. And that's where Vy equals 0. And that's at the peak. So let's say I throw something upwards, and then it keeps going up, 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 up. And then right over here, now it starts going down. At this moment in time, it's vertical velocity, right? Because I'm throwing it directly upwards. It goes to 0 meters per second, right? Because gravity has equalized it. That's called equilibrium. And this is, note, happens at its max height. And that's where the sense of the parabola can come in, because there's many ways to solve for max height with a parabola. But here we're just doing it vertically upwards. It's just straight up, straight out. Okay? So, here we'll use the, how high does it go? So here we can just use, so v final VO squared is 2d. Here we just use kinematics as always. And what are we trying to do here? Yeah, we're trying to isolate for d. So first, we grab this into the vertical sense, because remember, v final, that would be the vector, right? We always try and break it down. Even if it's a straight line, I always like to still break it down and just state that velocity x equals 0, um, like 2 meters per second, and then equals 0, right? Even if it's obvious, just state it. Make sure, like, show them you know what you're doing. You're the boss. You're a good person. So let's isolate here. V final minus VO. You could just um if you want, you could just very like do this, but I always like to keep it how it is, and then we divide it by 2a. Here you go. And now the final step is to add the vertical component into everything. So this is where things can get messy. There you go. So what is the final velocity? Well, like we stated, 0. minus initial velocity. Well, let's read the question. A ball is thrown vertically upwards with a speed of 15 meters per second. So that means it's VO equals 15 meters per second. And that's in the y sense. So VOY. I always like to, even though it's final and VO, I always had to add the components because, as always, these velocities have starting components and final components for every single component. So obviously, yes, it can get messy. You can do whatever type of subscript you want, but this is one I recommend. It's quite simple and it can be clear. And as long as you get into a habit, you'll be good. I promise you. So minus 15 squared and then divided by. So what's acceleration y? Well, vertically, remember, it's affected by gravity and no other acceleration. So 9.8. So what's dy? Um, oops, I forgot something. Gravity is negative. Remember that. The acceleration y, negative 9.8 meters per second. I could tell because I knew this was going to be negative. So, and distance can be negative. Anyways, so now we can just solve this problem. 15 squared equals 225. So negative 225 divided by 2 times negative 9.8 should equal to around 11.48 meters. But we can just confirm one more time. So negative 9.8 times 2, then negative 225 divided by that number equals 11.479. So around 11.48 meters. Okay, so how long is it in there for? Well, lucky for us, we have the distance now, so we can just use the other um, kinematics. So in this case, it would be V final equals VO plus AT. Okay, very nice, simple, very well. So we rewrite it with the y's equals VOY plus AYT. Remember, t is universal. Now we're trying to isolate for t, so it's y minus VOY and then divided by, sorry, AY equals t. So now just rewrite it one more time. 0 minus 15 divided by negative 9.8 equals time. So the time should be equal to around negative 15 divided by negative 9.8. It should be around 1.53 seconds. So there we go. Remember, as we learned before, these kinematics equations are extremely important. You'll be using them quite a lot. Obviously, later on, you will learn how to use other methods, which are much quicker, much better, much easier for solving these. But as of right now, these are the important stuff. You have to learn how to do this. You're expected to know this. And they might force you to do these because they find ways, right? They will find a way. And let's do, how much time are we at? This is a bit of shorter video, so we can do one more problem. So this is our last one. We've covered horizontal, we've covered vertically, so it's time to cover an angle. These can be a bit tricky, um, not in the sense of procedure, but in the sense of a lot of variables, a lot of numbers going on. These equations can get very messy. So yeah, so let's go angled launch, number 3. Let's use the example from before. A soccer ball is kicked at 20 meters per second. Okay. a 30-degree angle. So what does this tell us? Well, it's a vector and it's an at angle. So A and B. What is the ball's air time? What's the ball air time? So how much time is it in the air for? And then how far does it travel? How far does it travel horizontally? Because vertically it would be a bit too easy. So let's first write this diagram. How is the speed? 20 meters per second. Then let's break it down. Make sure that these lines are dotted and with arrows pointing in the correct directions, or else you might get marked down. So we have bx and by, and then this is v. So if you remember the equations, v equals v sine theta, and bx equals v cos theta, we can just, oh, the angle is 30. We can find these out quite easily. So let's begin with the horizontal one, the horizontal component. Um, so this would be 20, 30, and then this would equal to round. Alright, sorry about that. So 20 goes 30. That would be around 17.3 meters per second. You don't have to put that, but you should. You really should. It's very important. And then we can just box that up, and then by equals v20 sine 30. So by should be around 30, should be around 10 meters per second. Oops, so done that. So there we go. So now that we're done with that, let's actually try answering the questions. So, what's the ball's airtime? What's the ball's airtime? Well, we know that time is universal. So we can just choose the easier one, vertical. So if its vertical component is 10 meters per second and gravity is around 10 meters per second, well, we can do the math. So let's use the equation from before that we got. So sorry about this. I'm just trying to remember.